continue with our spatial selection, and now we will use select by location tool. Question 7, select the feature from the dataset soil map adjacent to features with soil name alpha soils. What will be the source feature of this selection? How many features are selected? So here is our soil map, right? And here is soil name alpha soils. And here is our soil samples. We don't need them. So first, let's select alpha soils, right? Soil name alpha soils. So here we have two polygons, and we should select features that are adjacent to these polygons with this soil name. So let's go to select by location, and here is our target layer is still, I think, soil map, and and here also the source layer is also soil map. See, it's automatically selected. So you selected features, right? So we already selected two features, and here we should find the spatial selection method for target layer features. So we're selecting from soil map using a source layer as a soil map. So we can use the same spatial dataset as both as target layer and a source layer, but mostly we will use different spatial datasets for these purposes. And let's find adjacent. So adjacent is within a distance, contains the source layer, completely contain, within the completely, within are identical, touch the boundary of the source layer feature. So touch the boundary are the source of the source layer feature is the adjacent, right? Adjacent feature. Adjacent to the synonym of adjacent. So let's click OK. See that two additional polygons have actually all polygons have been selected because they're all adjacent, right, to this polygons. So you use the spatial relationship are within a distance of, but you can use another spatial relationship to make same selection. Which one? Check the comparing both results. So we actually used selection, touch the boundary of, but we could also use are within the distance of the source feature, right? Are within the distance of the source feature layer. So let's make clear selection again, and now again select blah 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 alpha soils, and here is the distance is 0 meters, right? Within the distance of the source feature layer. So soil map, and here is soil map. Soil map are within the distance is 0, right? So in the previous exercise, in the previous question, we used touch the boundary, and within a distance of the source layer feature of 0 meters is almost the same. It will give the same result, as you can see, right? So I will just make a print screen of this selection. So within a distance of 0 meters from soil map, you selected features. No, not this one. 0, alpha soils and alpha soils. Soil map, and 0. So two features are selected. Again, okay, right? See, so are within the distance of soil map. So let's make a print screen here. Actually, it's already selected 6 features, but we at first initially selected 2 features. Okay, never mind. So the question C, select the features from the dataset LULC vector that are within 200 meters from the soil feature with the soil name alpha soils. how many features of the LULC vector dataset are selected. Clear the selection. So now we will use two different spatial datasets to make selection by select by location. So first, we should try to understand the meaning of the question and meaning of the query. Select feature from the dataset LULC vector. So the target layer is our LULC vector. So that are within 200 meters from the soil feature. So within a distance of the source layer is 250 meters, right? 250 meters, and the source layer is our soil map, but we only need here a soil name alpha source. So for this we go to select by attribute. So we can just click here and see that use selected features is clicked, activated. One feature is selected, so we're choosing polygons from LULC vector using the source layer of soil map alpha soils within a distance of, here is 250 meters, right? 250 meters. Let's make a print screen of our spatial selection, and let's activate here. So we see that 39 polygons have been selected from the LULC vector. See, we can just close here these polygons, right? Mostly. Let's change our colors to so see this polygons have been created. They are within a distance of 250 meters from this soil name. So 200 meters, it select from the LULC vector all polygons, right? So I hope now it's clear. Write down the so clear the selection again. Write down the code of the soil points dataset soil samples samples that fall completely within the soil features classified as anti-soil. Write down the code of the soil points. So at first we go to we don't need LULC vector, so we go to soil map and choose anti-soils. So here is our polygon, right, which contains soil name anti-soils, and that completely fall within the soil features classified as anti-soils. So again, we go to select by location. We need our soil samples with the target layer from the source layer soil map. Use selected features are completely within. We can find here completely contain the source layer feature, right? Are within the source layer feature, are completely within the source layer feature. So this one is the most appropriate type of selection to our spatial query. And let's click OK. See, only one soil sample answers to our query, right? Point ID 9 and soil code 14C, etc. So we just can make a print screen here of your both of your attribute as well and of your soil map. So what is the code? The nearest soil point to the road named Champs. To answer this question, you will have to create a spatial join between the roads and soil dots. So let me finish video here, and we will continue from the next video. It is